take a close look at the question. It's a very simple question where box of x square minus x plus modulus of minus x plus box of x is given. You need to test the continuity at x equal to 0 and at x equal to 1. This is a simple question, I agree. But I will give you a simpler solution for this. And look at the solution, what we exactly do. The function fx, which can be here factorized into two factors inside the box, plus a simple mental calculation will tell you that minus of x minus box x, this one, is equal to minus of fractional part of x. A modulus on this is a modulus on this is equal to simply the fractional part of x, and that means here we have simply the fractional part of x. Now continuity checking can be done using the definition of continuity, but there is a simpler way. We take a graphical approach here. Let's say this is your x-axis and let this be the y-axis with 0 here, let's say 1 here, and let's say 2, and let's say this is 1, and let's say this is minus 1. Now at this level we take a ceiling for the fractional part of x and we draw the graph of x into x minus 1, the quadratic opening up, passing through 0 and 1, roots at 0 and at 1. That means the quadratic will have approximately this type of a nature, and let it proceed like this. Now on this quadratic, if I apply a box, the box here at least to the left of 0 will be equal to 0 because the level of 1 is not yet crossed, and that means this particular box value will be from here and to the left be at 0, will be at 0 from x equal to 0. That means this is valid for x less than equal to 0. This is valid for x less than equal to 0. Now again look at 1. At 1 this value is 0, so box value is going to be 0, and ahead till I reach the level of 1 this particular function is going to be having box value 0 because it is below the level of y equal to 1. This is the line of y equal to 1. But what about between 0 and 1? And this is valid for x greater than equal to 1. What about in between? In between, this is a negative value, and obviously the minimum value is at half, and this is half into minus half, minus 1 by 4. Box value is going to be minus 1. Open-ended from here, it is going to remain till this point open-ended, and it is going to finish. That means this is valid for x greater than 0 and less than 1. This is the graph of, let's say, g of x. This and this is the graph of g of x. Now what about the fractional part of x? The fractional part of x comes from, let's say, minus 1 and rises like a straight line till this point, and here till this point, let's say it reaches at this point with this graph, and it reaches, let's say, at this point with this graph. Now let's add up these two and it's going to be pretty simple. To the left of 0, now let's talk about f of 0 minus. That means at this point this is close to 1, this is at 0, we are having 1 plus 0 equal to 1. F of 0 exactly at 0. This is the fractional part function at 0, and this g of x function is at 0. That means this is 0 plus 0 equal to 0. Now see, there is a breakage, there is a discontinuity. We need not go ahead here, but still for the sake of understanding, at 0 plus, let's say at 0 plus, this is, let's say, 0 minus, this is, let's say, 0 plus. At 0 plus, I am very close to 0 with this value, and I am at 0. I am at minus 1 with this value, and that means the addition is going to be 0 minus 1, which is equal to minus 1. This tells me the function is discontinuous at x equal to 0. This is the conclusion for 0. Now what about at 1? Now let's say 1 minus, let's say this is the position for 1 minus. Well, how do you look at this? This value is at minus 1. Whereas at this point, if you look here, you are close to 1, and that means f of 1 minus is equal to 1 minus 1 is equal to 0. And what about at x equal to 1? That means at exact 1, x equal to 1, this value is at 0 and this value is at 0, and therefore 0 plus 0 is equal to 0. What about 1 plus? Just to the right of 1, let's say this is the position of 1 plus. Now look at the fractional part function, it's at 0, and this box function, it's at 0. That means here again I am at 0 plus 0 is equal to 0. This tells us that the function is continuous at x equal to 1, and hence these two things bring you the answer as equal to option B. This was a question from JEE Mains 2023. Thank you for your patience and see you in the next question.